Okay, in this case, we are asked to find I1, I2, and I3. I think we need to use the Kirchhoff's rules here, which is we have two, which is the Kirchhoff junction rules and also the Kirchhoff loop rules. Okay, but I think we need to complete this diagram first, because I need the sign of the voltage of the resistor, because that will be very important in our problem solving. Okay, now here I1 is going here, and eventually it will turn and it becomes the current that pass through this 4 ohm resistor. And I think I will give the sign here where the current came from, that will be positive side, and then where the current goes to, that will be the negative side. Okay, this will be very important later. Okay, and here I2 going up, and eventually it will goes to the right. And remember our convention, where the current comes from, that will be positive sign, and where the current goes to, that will be negative sign. And we can also do that for this I3 here. I3 is going down, and eventually it will goes to the right. So the positive sign will be here, and then the negative sign will be where the current goes to here. Good. And then for the battery, we already given the negative sign is here and the positive sign is here. They will be very important when doing the loop rules. But the first thing that I need to do is the junction rule here, because that is the easiest to see here. Okay, let's do that. Let's do the Kirchhoff's junction rule. What does the Kirchhoff junction rule say? It said that the sum of the current that goes into a node will equal to the sum of the current that goes out. And the only current that goes in is this one. So I will have I1 here. And I2 and I3 both going out. So we just need to add them up, right? So I will have I2 plus I3. And I think nothing that we can do from here, not very helpful at this stage, but it will be very helpful later. So let's save this as equation number 1. Okay, now we also given two loops by the problem. Let's name this loop here as loop 1 and the other loop as loop number 2. Okay, now let's do the loop rule at loop 1. Loop rule at loop 1. Okay, the loop rule said that the sum of the voltage in a loop will equal to 0. The sum of the voltage will equal to 0. Okay, or actually in physics we usually use this symbol, the difference of potential. Okay, and remember that the voltage is current times resistance. Remember Ohm's law, right? So we will have this one. The first one is I2 multiplied by the resistance, right? So 5. But here the current is entering the loop is entering from the positive side, right? So the loop here is entering from the positive side, so this one will be plus. Okay, and then let's move on to the other resistor. So here we have different case here. The loop is entering from negative side, so I will have minus sign here. So I have minus, and then remember the voltage is current times resistance, and the current is I3, and then the resistance is 9 ohm, so I have 9, and all of that will equal to 0. Good. Now I2 times 5 and positive, I will have 5 I2, and here I will have minus 9 I3. Okay, and all of that will equal to 0. Again, nothing that we can do, but let's save this as equation number 2. Okay, now let's do another loop rule, but this time at loop 2. Loop rule at loop 2. Okay, and let's start from this battery here, and the loop is entering from the negative side, so we'll have minus sign. Okay, I think I will write the formula first. The sum of the potential difference will equal to 0. Okay, and here the loop 2, the loop will enter from the negative side, so I will have minus sign. And then we already have potential difference, which is 6 volts, so I will have minus 6. Good. Okay, now let's move on to this, and the loop is entering from the positive side. So again, I will have plus sign here. So I will have plus, and then remember the voltage is current times resistance. The current is I1. And then what is the resistance? 4 ohm. So I will have 4 here. Okay. And what can we do next? Okay, now the last resistor here. Remember the loop is going here and then pass through here. It's not pass through this one, right? This one, the 9. The 9 ohm resistor. So it will enter through this positive side. So I will have plus, and then the potential difference or the voltage, that will be I3 times the resistor, which is 9. And that will equal to 0. Okay, let's rearrange this. So I will have 4I1. Okay, and then plus 9I3. And that will equal to 6. And we will have this as equation number 3. Now we have 3 equation and 3 variables, right? 1, 2, and 3. I think we can plug this I1 into this one, right? So let's do exactly that. So I will have 4, and then this one will be I2 plus I3, and that one will be 9I3, and then that will equal to 6. So we will have 4I2 plus 4I3, and then plus 9I3, and that will equal to 6, or we will have 4I2 plus 13I3, and that will equal to 6. Okay, that's good. Now let's use this equation number 4. Okay, but here in equation number 2 and number 4, we can solve it, right? Because this one is I2, this one is I2, and this one is I3, and this one is I3. That is 2 variables with 2 equations. So let's solve 2 and 4. Solve 2 and 4. And the fastest way to do it, I think I will use calculator, right? Okay, let's set this up. And our calculator for equation is number 5. And 2 variables is number 1. Okay, let's plug that in. So I will have 5. And then minus 9. And then 0. Okay, and then 4. And then 13. And then 6. Okay, we will have the x value, which is 0.535, which is the value of I2, 0.535. Okay, what is I2? I2 is 0.535, and the unit here will be in ampere. And then what is I3? I3 is the y value, right? So we will have 0.297, 0.297, and the unit is in ampere. And then for I1 is just sum of them, right? So I will have I1, let's just add them up. Okay, let's just add them up. So we will have 0.535 and then plus 0.297. Okay, 0.832, 0.832, and the unit is in ampere. And I think we have achieved our goal here. I think that's all. Thank you for watching. See you in the next video. Bye bye.